Hello, everyone. Today we are going to talk about the interesting weather that we experience here in the United States. It all starts with something called air masses. So think about the last time the weather suddenly changed. Maybe it went from warm and sunny to cold and stormy in just a day. What you experienced wasn't random, it was the movement of something huge, which we call an air mass. So today we're going to explore how these massive bodies of air shape our weather and how they lead to things like thunderstorms, tornadoes, and hurricanes. So what is an air mass? It is an enormous body of air that has similar temperature and moisture throughout. And air masses are huge. They're about 1,000 miles across. So let's visualize how big an air mass would be. Let's put Marshall, Minnesota, right at the center of this air mass. Around it, we have Wisconsin to the east, along with Lake Michigan. To the north, we have Canada. To the west, we have North and South Dakota. And to the south, we have Nebraska and Iowa. And then this air mass would extend even further into the south and go into Kansas and Missouri and around to the east in Illinois. So if we imagine 500 miles in each direction, we're stretching out to the Lake Michigan in the east, up to Manitoba, Canada, up by Winnipeg, Canada, to the north, over in the west, we're in the Black Hills, and to the south, it's Kansas City. So that entire region would just be one single air mass. So when this air mass moves, it brings weather with it. And that's why we experience widespread, similar weather across the upper Midwest. Now, air masses don't just form anywhere, they get their characteristics from their source regions. So there are three types of temperature: Arctic, polar, and tropical. And there are two types of moisture: continental, which is dry, and maritime, which is moist. So let's look back at our example over Minnesota. The region that typically falls under continental polar air mass is cold and dry, especially in the winter. So let's look at the temperatures in January. In Winnipeg, average temperatures are about 25 degrees colder in Winnipeg than they are in Kansas City, within the same air mass. Looking at precipitation, Midwestern winters are pretty dry, so even though we even though we get a lot of snow, it doesn't really necessarily translate to a whole lot of precipitation. When we compare Winnipeg to Kansas City, there's about a 15-inch difference annually in temperature, with Kansas City receiving more air. That makes sense because warmer air can hold more moisture. Now let's shift to the east-west differences. Hill City, South Dakota, Marshall, and Kewaunee all have different temperature patterns. So Hill City sits about 5,000 feet higher in elevation than Marshall and Kewaunee. And remember, air temperature drops about 4 degrees for every 1,000 feet in elevation, which is a huge factor. But elevation doesn't explain everything. Moisture plays a role too. So as air rises over the Black Hills, it cools and forms clouds and adds moisture that moderates the temperature, making Hill City warmer during the winter days and cooler during summer nights. Over in Kewaunee on Lake Michigan, we have a huge body of water that moderates the temperature, and it makes the summers a little bit cooler and the winters a little bit warmer compared to places like Marshall. Another cool effect, the lake effect, um, happens when we have an increase in snowfall when that cold, dry air passes over the relatively warm, moist air above the lake. And it dumps down more snow than we get in Marshall or the hills. They get about a foot more snow in Kewaunee than we do in the hills or in Marshall. So obviously, we live in the continental under a continental polar air mass, but there are other huge air masses around the US. So first, we're going to start with one that's not in the US, Arctic, which is cold and dry. We find that at the polar ice caps. It's always cold, always dry. Maritime polar air masses would be what you would find in the Pacific Northwest. So they're cold because they're in the northern latitudes, but they're also wet because they're right next to the ocean. We also have maritime tropical, which are warm and wet. And so we find that in the southeastern United States, where they have lush green grasses growing and lots of plants, and it's a little bit more mild temperatures in the winter. And then finally, we have the continental tropical air mass, which kind of hangs out over the southwestern US around Arizona, New Mexico, southern Utah, southern Colorado, and it's warm and dry. Now let's move on to something called a front. A front occurs when two different air masses meet and they do not mix. First, we're going to talk about warm fronts. When warm air meets cold air, the warm air rises over it in a process called overrunning. This creates nimbus clouds that lead to steady, gentle rains. On a weather map, warm fronts are usually shown as red lines with semicircles. To me, they look like little red bubbles. So here's a challenge for you. Look up the National Weather Service forecast map and find a warm front. Pick a city in the direction that the front is moving and check the weather. You'll likely see clouds or rain. Now moving on to cold fronts. So cold fronts are steeper and they move faster than fronts. The cold air pushes under the warm air, forcing it upward quickly, and that rapid rise creates large thunderstorm clouds, which we call cumulonimbus. On a map, cold fronts generally look like blue lines with sharp triangles, like teeth. Similar to the warm front, try to see if you can find a cold front and thunderstorms that are ahead of a cold front. Because they move faster, cold fronts eventually catch up to warm fronts, and they actually run into the tail end of another cold front. And when that happens, we get what is called an occluded front. In an occluded front, the warm air is lifted off the ground entirely. During that time, we get prolonged precipitation, sometimes leading to flooding. On a map, occluded fronts alternate between the semicircles and triangles and are usually shown in purple. Now let's zoom out and look at the entire United States. So we have this continental polar air mass that's cold and dry moving down from the north. At the same time, we have this warm, wet, maritime tropical air mass that's moving in from the Gulf. Where these two meet, we get a rotating system called the mid-latitude cyclones. These systems are responsible for much of our severe weather, so thunderstorms and tornadoes, that we see in the upper Midwest. Hurricanes, on the other hand, form over warm ocean waters, especially in the late summer after the sun has been heating the Caribbean Sea and Atlantic Ocean. That rising air condenses as it rises and then falls back down, cooling the surrounding air near the warm water. And it constantly is circling up and down and it starts to swirl using the Coriolis effect. That's all I've got for you today. Have a great rest of your week.